introduction to logs by going over what an exponent is. So remember, our exponents look like this. F of x equals b to the x power. Remember, this is an example. 8 to the second power. This 2, that is our x, which is our exponent. And this big 8, that's our b, which is our base. Alright, so the logarithm, or we're just going to abbreviate it and call it a log, is just another way of writing these exponents. So that's why I went over what an exponent is. I forgot up here. Remember, what does this mean? This means 8 to the second power means 8 times 8, not 8 times 2. So if I take 8 times 8, then that's 64. So 8 squared equals 64. All right, let's look at how these two relate to each other, what log form is and how it relates to our exponential form that we already have up here. So we're going to have log base b, that's a subscriptive log, of a equals x. Let me actually erase that and redo that. Okay, so we're going to have log base b of a equal to x. Okay, so that's our log form. Our exponential form is up above that I have. So b, base b, to the x power equals some number, which is a. So I did these in the same colors, so I rewrote it. This base b of our log is the base b of our exponent, our exponential function. This a of our log, what we're taking the log of, is what our exponential expression equals to. What our log equals to, the x, is what our base is raised to. Okay, so let's look at these examples here, and it might, hopefully, will make more sense. So we're going to go from log to exponent. So from this form to this form. So we've got our log base 3 of 9 equals 2. So do you hear how I'm saying that? Log base 3 of 9 equals 2. That's how you read these log functions. So let's label. We got log base 3 of 9, that's our a, equals 2, that's our x. So I'm going to write that in my exponential form. Base is 3, x is 2, and it equals 9. Well, let's see. This means 3 times 3, right? Not 3 times 2 equals 9. Does 3 times 3 equal 9? Yes, it does. So this makes sense how they can go back and forth. Let's look at another example. So log base 4 of 1/16 equals negative 2. So let's rewrite that into exponential form. Base 4 negative 2 equals 1/16. Okay, let me back up here just to remind us about when we are raising to the negative power. That means that we are taking 4 squared, which is 16, but that negative means that that number that we get goes underneath a fraction. Negative exponent means that number goes on the bottom of a fraction, 1 over that. All right. Log base 9 of 27 equals 3 over 2. Base 9 of 3 over 2 equals 27. That's it. Log base, that's a b, base 2 of 16 equals 4. 2 raised to the 4th power equals 16. Easy peasy. We're just rearranging our numbers. Okay, let's do the reverse this time. Let's go from exponential form into log form. Again, we're going to just label the same things and then put them into our log. So we've got 14 to the 2nd power equals 196. So our 14 is our base, the 2 is our x, that 196 is our a. So we've got log base 14 of 196 equals 2. Let me rewrite that. I want you guys to make sure when you're writing this out to be very clear. This is log base. This little base number is a subscript. So like if we were typing this, it would be normal font, and then this would jump down and be tiny little font down here. Make sure you're writing it like that so that when you write 196, again, we're back up to big font. The reason why I make a comment about this is because if you write all of this the same, then it ends up being log base something of 14,196. If you write all these numbers all together, it's not going to be the same thing. All right, 12 to the 1st power. So 12 is our base. Our exponent is our x and a. Hey, that's a good way to remember that, right? Exponent is x. So log base 12 of 12 equals 1. Base is 2. Exponent is -3. My a is my 1/8. Log base 2 of 1/8 equals -3. This is it, guys. Same thing. Base 8, x is 4 to the 3rd, 16 is a. So that's log base 8 of 16 equals 4 to the 3rd.